Hello everyone, this is Jonathan from Leica's Mobile Mapping Support Group. In this video today I want to talk about Inertial Explorer processing of trajectories. So this would be applicable in phases where you might want to have a little bit more control over your trajectory processing as to what inputs you give it, and to do a little more QA of your GNSS solution. So Inertial Explorer runs in the background of Cyclone Pegasus Office, but you also have access to a standalone version of it where you can do your trajectory processing on your own. Following the trajectory processing on your own, you would be able to have a .cts file that you could use in the import trajectory option of CPO. So this bypasses the trajectory calculation step of CPO because it's already been done. So the way that we go about doing this is first we open Inertial Explorer, and then up here in the top left-hand corner, we have the Project Wizard. So I'll click the Project Wizard. You can see we have the option to go next to begin our project. So the first thing it's going to ask me to do here is create a project. So what I will do is I will browse to the folder where we want to create our project. In this case, we're going to continue our US Summersdale clone project. We'll go in the job folder, and then in the trajectory folder. So you can see there's already Inertial Explorer projects created. These are the ones that were created by CPO. I typically like to go in here and create a new folder, and I call that folder IE if I'm going to do a separate Inertial Explorer project. So I'll open my IE folder, and we will call this Video Test IE. And that will be our Inertial Explorer project. So once we've selected that, we click Next. So the first thing it's going to ask us for is GNSS data. So it's looking for the rover data from our system. So Pegasus or TRK, that file is a .gps file. It contains the GNSS data from the span along with the IMU data. So we'll click Browse. You'll see if we go in the trajectory folder under rover, since this is TRK data, this is the way that's split up. You'll see we have GPS.gps here. This is the file. You may only just see this file if it just came straight from the system, because Inertial Explorer converts GPS to GPB. GPB is going to be Novatel's format. So what I'll do here is I'll select GPS so you can see how that works. And you can see it already detected the IMU data and checked this box for me, so I don't need to fill that in. So I'll click Next now. It's telling me it already exists. I'm going to overwrite in this case. You'll see the conversion here is done. So this is converting my .gps to GPB. So next, it's asking for the antenna height. Here I'm not going to add any sort of offsets because it's set from the system. And now here we have the option to add our base station data for post-processing. So we have the option to do PPP processing, in which case it requires the precise files to be downloaded, or if we want to add base station data. So in our case, we do have base station data. I went on the Core's website and downloaded a base station for this project. And I also want to leave download precise files turned on here because I want the ephemeris data from the satellites downloaded. So after I click Next, you can see it automatically goes to download the precise files. And I'll pause recording while it downloads these. Okay, so my precise files were downloaded, and then the next screen that pops up here is where we add our master or our base station data. So we can add a station from file. We can add a station from download, which will look around the rover files location for the nearest publicly available base station. So in my case, it might be a core station, and then download it. Or I can just add station from file if I have it on my hard drive already. In this case, I already have it on my hard drive because I downloaded the data directly from the Core's website. So I'll say Next here, and then I'm going to browse to the file path of my GNSS data. So I have put it in my master folder here. You can see it's already been processed through CPO as a GPB, but I'm going to start fresh, and we'll just select this 23.0 file for this NIGC base station. So click Open. It detected that it's Rhinex format, and then when I click Next, it's going to ask me if I want to overwrite my GPB file because it already exists. I'll say yes. And then the same thing's done here, where that Rhinex data is converted to GPB for Inertial Explorer to digest. So now here is where we would put in our precise coordinates, if we had any. In my case, I didn't look up the data sheet, but this is where you would add your precise coordinates. You have a couple other options here too. You can compute from PPP. You can use the average position, MSL height. You can enter the grid files. Sometimes I'll compute this from PPP if I decide to, if I don't have precise coordinates. And then we put our datum in here, which in this case is going to be WGS84. And then I believe mine's 2010. It automatically detected the receiver model of the base station data, so then we'll just move on to the next. So we've got everything loaded that we wanted to. So I've got my precise files, I've got my base station data loaded in here. It's going to show me readout of everything that I put in. So I've got my GNSS antenna from the TRK, IMU data from the TRK, the base station data that I've added, and then the precise orbit and clock files for the satellites that I've downloaded. So once I see everything that I need here, I just click Finish, and then we'll see a preview of our data. So we'll see this is a, let me zoom in here. We'll go to our Plot Results tab first. So the first thing that I like to do when I open a file like this is just verify that my base data overlaps the rover file. So when I click plot results here, you see we have a bunch of different plots, and we can double click and launch all these plots. But the first thing I'm going to do is I'm going to look for file data coverage. I'll double click that, and you'll see it selects all of my files here. And what I want to look for here is just to make sure that my file data coverage overlaps. So this is my base station NJGC, and I just want to make sure that it's overlapping these two files. So the other things that you can see on this is all my IMU stream data is blue, my GNSS data is green, and then these orange bars up here are actual camera events where the TRK was triggering. So you just want to make sure that all that's covered. This is also helpful to see, let's say that we were to have a problem area in our trajectory, we can take a look and see where and which track we might be the most affected by the trajectory problem that we had. The main thing I wanted to check here, though, was that the file trajectory is good and the base station data overlaps the rest of the trajectory. So I'll say OK to that. And then this is where we move on to actual processing. So we've got our base station down here, and then we've got our data here. This probably looks familiar if you've watched any of the other videos. So what we'll go to next is we have a button here for process TC for tightly coupled. So that's what you're going to be using with your mobile mapping data. You can see it even has a picture of a vehicle here. And we'll go into the options that we get here. So in most cases, the way that I run it, I usually check on multipass. This will make multiple passes across the data to smooth the GNSS solution. We leave both directions checked on. This provides us with forward and reverse processing. The profile is already detected as a span ground vehicle. So this is the one that I'm going to use because it's set up for a ground vehicle. And then we have under advanced GNSS options, there's not much that you would want to change here. You might increase the elevation mask if you're in like a urban environment or heavy canopy where you might want to increase the elevation mask. You also have L1 lock time cutoff where you can increase this if you want to increase the amount of time required for it to accept data from a lock. And then the other thing under ARTK that sometimes you might want to change is the quality acceptance criteria. So right now this is a max quality acceptance criteria. You can reduce that if you need to, if you're having more trouble getting a solution. So I'll say OK to this. Go into the advanced IMU options so you can see what's there. The only things that you might want to adjust here, this is where you would add vehicle constraints. So this would prevent sudden movements in these directions. So if I had an X, right now it's 0.3 meters per second. it would prevent any sort of shift in the position by that speed or distance. Let me see if there's anything else in here we need to go over. Coordinate updates can come from here. The DMI data, we can enable DMI data and add it here, browse to the file to put that inside the IMU solution as well. I'm not going to make any changes here. We're going to go with defaults. The only other option that you have here, you can, instead of process directly, I click the process directly button and we started the process, but you also have the option to compute the lever arms of the system. So you can pull that process drop down and recompute the lever arms if you so choose. So once this processing is started, you'll see we'll go through this is going to take a little while, so I'll pause the recording again while it runs. But it's going to run through multiple passes forward, multiple passes in reverse. You can see both windows running each way. Once I think it'll go through 2 or 3 passes here. And once this is finished, then it will smooth those solutions to combine them together, and then we'll come up with our .cts file, or our final solution. We'll go over our some graphs, and then we'll be ready to take that into CPO. So I'll pause this, and we'll go from there whenever it is finished. Okay, so that finished up the processing phase. So now we can zoom in here and see that we actually have trajectory quality and ARTK nodes here where we've got lock, and the rest of the trajectory is looking pretty good. So a couple things. At this point, the CTS is created, so we could go into CPO and immediately use this trajectory. We don't need to do anything else here. I typically save the project just out of habit. But the things that we might want to take a look at once we finish this, or we might go back to plot results. And you see we have a lot more options now available to us as far as things we can look at. Feel free on your own time to go through here and test out some of these plots, but I'll select a few of them that would probably be beneficial to take a look at. So estimated position accuracy, that's a good one to take a look at. Here we've got, looks like that's a centimeter, I believe. Yeah, that's in metric over there. So we've got about a centimeter in the vertical. In some places it's jumping up to 2 centimeters, and then we're down below a centimeter for most of the horizontal. We'll take a look at the number of satellites. That can be important. Looks like we do have a little drop in coverage right here. And then we'll also take a look at combined separation with fixed ambiguity. So this is what the combined separation between the plots is whenever it's fixed. So we have one spot here where we've got a kind of a spike in Z separation. You can see that that's also manifests itself down here in the data. And this is based on the fixed ambiguity of the GNSS solution without IMU. So the other thing that I would typically take a look at here might be the quality factors. So this is just going to show us our quality factors. So for the most part, we've got Q1, and then it spikes up to 3 in a couple areas as well. But that's it, and then you can take these and output them into a plot. A couple other functions that you might want to use in here. There's an output function that will allow you to output to Google Earth. So that will basically export this trajectory as a Google Earth file that you can open up as KMZ and then view all of these information there. That can be very useful. And then there's also an export wizard function here where we can go and, like, let's say, like a Pegasus here would export this as a text file where we have the individual second by second epochs that are going to come out for importing into other softwares. There's a couple other tools in here. You can convert raw GNSS to GPB. That would be like taking your Rhinex files and converting them to GPB. You can also download service data independently if you want to download CORS data here. And then the other thing that you might want to do would be resample. So this concatenate, slice, and resample will take a file. Let's say, for example, you have a base station that's 15-second sampling, but you need 1-second sampling data for your project. You can then resample that base data to be 1-second interval so that they'll match up. But in a nutshell, that's pretty much it for Inertial Explorer if you're going to do processing of a project on your own and then bring that CTS in later. So if you have any questions, feel free to reach out to the mobile mapping support email, and that'll be it. Thank you.